Hi everybody. Today we have a viewer question from my blog site that's carrying these articles and videos. And the question was basically, how is nothing better than randomness as an explanation for the universe? And it was a pretty well posed question, so let's take a look at it. Paul asks, scientific materialism says that the universe is random, and you say that that is not a proper answer. I agree. But you say that the universe is nothing. This seems like a parallel statement. So basically he's saying that substituting the universe is nothing for the universe is random seems like it's, not really helping the situation, right? So what is lacking from the universe is random, but is answered by the universe is nothing? So that is actually a very excellent question, because after all, the concept of nothing is quite paradoxical, isn't it? That something is nothing. So basically, we need to understand what we mean by nothing, right? So how is nothing a better answer than random? How is nothing a better answer than random? Perfect. Great question. So what do we mean by nothing? So first of all, like I said in that last video, let's just be clear. By nothing, we do not mean it in a nihilistic sense. We do not mean it in an emotional sense, either negative or positive. It's not an emotional conception at all by nothing. We don't mean no emotion, right? We don't mean no thought. We don't mean anything like that. We don't mean it in relation to meaning, that it means that the universe is meaningless because it's nothing. That's not what we mean by nothing when we use the term nothing in ontological mathematics. We don't mean that the universe is purposeless because it's nothing. Okay, so those are not the sort of nothings that we mean. Okay, we don't mean it in a sense relating to non-existence, because after all, with ontological mathematics, we are explaining why existence exists, right? And that it reduces to a net nothing. Okay, but by that we don't mean it in any of these sort of terms, right? So how exactly are we using that term nothing? What do we mean by it? As I said in that last video, we mean it in a completely logical sense only in a completely logical sense. Okay, but the question is, how do you demonstrate that? What do you mean by in a completely logical sense? Well, we mean it logically, which is to say how. So of course, how are we going to say it? Ontological mathematics. What's it all about? It's about mathematics. The whole theory is about well, here, let's get into it. Ontological mathematics is the position that existence must be rational, and ultimately, therefore, if you work that all out with the principle of sufficient reason, what does it mean? It means that existence must be expressed as a mathematical structure, substance, or language. Existence, that's what existence is. Existence basically becomes made of mathematics, right? And that's what I've shown in the previous videos with the circling and something reducing to net nothing through the circle, and how that can only be expressed mathematically, right? So something is a net nothing. It's not an absolute nothing, okay? We don't mean that it's an absolute nothing, that it's an illusion that doesn't exist. It's certainly real, but we mean that it is a logical net nothing, a resultant nothing. Existence is definitely something. I mean, it's definitely something, and we're definitely in it, and we're definitely experiencing it, and we're definitely part of it. And it's definitely real, right? But it is a net nothing. It is a something which reduces to a net nothing. Therefore, as we covered in that previous video, still satisfying that proviso that only nothing can be the self-existent, and therefore avoid the infinite regress problem and the mystical or magicalness problem. Okay, so we mean it in a totally logical sense only, right? So how can that be demonstrated? Well, only math can demonstrate how that can possibly be. So how can math show that? So the person who asked this question, Nepal, I think that he's a student in physics or maybe a graduate by now. So he'll know this equation. So for example, how can you show it? This is how you can show the concept. This is how you show it conceptually. Okay, so look at on the left side of this equation. Now this might seem trite, but it's really not. I mean, you might think that this is a simple equation. Certainly a graduate in physics will have, this would be such a trivial result to them by now. But still, just appreciate it for what it's saying, all right? There are all of the operations in mathematics are happening on this side. All of the fundamental operations of mathematics are happening. You have constants, like very, very important constants from mathematics as well. You have the logarithmic constant, and then you have the exponentiation. You have the imaginary number, so you have a complete complex number set here, an algebraically complete set here. You have pi, one of the most amazing important constants of mathematics. You have the addition, and of course you have multiplication right in here between the I and the pi. You have addition, then you have 1, and you have a 0. Like, what important numbers? 1 is obviously, I mean, that's the first number basically, right? 0 is obviously also basically the first number. So you have a lot of stuff happening here on the left-hand side, but it all equals 0, which is nothing. So what do we mean by it? So this is what we mean by it. We mean it logically, which is to say mathematically. That's what we mean when we say that ultimately existence has to be nothing to get around that problem of infinite regress or the appeal to the mystical. And how do you show that? Well, only math can show that. Only math can show how something like that is possible. How does something quite real still reduce to nothing, a net nothing, and thus get around that problem of infinite regress and appealing to the magical? Here it is right here. It's showing it to you right here. Isn't that amazing? It's really, really, truly beautiful and astounding. It's right there. All sorts of action happening on this side. All of the operations of mathematics, including the algebraically complete complex number plane, is all contained here. All of it. All math is basically here. And it all reduces to nothing. So you see, there's no emotion in this. There's no, it doesn't mean that it's meaningless. It doesn't mean that it's purposeless. It doesn't mean that it's nihilistic or anything. In fact, it means it's amazing. It's astounding. Like, it's mind-blowing. It's amazing. Don't you think it's amazing? Look at how wonderful that is. We have proven how existence can exist. We have avoided for the first time in history the problem of infinite regress or appealing to the mystical. Isn't that amazing? It really shows it right there. In a simple way, sure, but it shows it nonetheless. And of course, what is Euler's identity? What does it come from? From Euler's formula, of course, the complex number plane. Euler's identity comes when pi is equal to 0. So e to the I pi is cosine pi, which would be -1 plus I times sine x. Sine of pi is 0, so you just have e to the ix equals -1. So you just put that over, e to the ix plus 1 equals 0, right? But basically this, if you look at it in terms of this whole equation, you get the same result, right? This is the circling in the complex, which is the complex number plane, which is the algebraically complete set of numbers, right? It's algebraically complete. There's nowhere else to go. That's all numbers. Contains everything you need, real and imaginary numbers. There's no numbers outside this. And of course, you go around as the circling. You go around in one full cycle, and you get what? Of course, Nepal would know this. Of course, he can do an integration or a sum to see what is the total vector value around this whole circle. And what is it? It's 0. It perfectly balances. What else could do it? What else could perfectly balance? What else is precise enough? The English words aren't. Spoken language sure isn't able to balance perfectly. And of course, you know, from my previous videos we've discussed about Gödel's incompleteness theorem, you know, spoken language is terrible. It's illogical and it's not complete. Basically, in a mathematical sense, human spoken language is not algebraically complete. It's incomplete, and it will say illogical things, and it can't balance itself, right? But math does perfectly to the infinite decimal place, right? To the infiniteth decimal place, balances perfectly at 0. And math is the only thing that can do that, and it does do that. So isn't that wonderful? How beautiful, how amazing. Gosh, that's great. Okay, so what's the difference? So there's Nepal's quote, just for a reminder if you want to see it again. So the difference is that, philosophically, yeah, The difference is that randomness has no ontology. So ontology is the branch of metaphysics that studies the nature of existence or being as such. So um, what are the properties of randomness? How random is randomness? Is it completely entropic? Is there some sort of signal in it? Is it completely flat? Is it Gaussian? What is it? You know, is it normal random? Is it linear flat random? What is it? You know, that's never been defined. We have no idea what randomness is, right? Has no ontology. It's never been explained why it should exist. This gets into epistemic justification, why it should exist, you know, and what form it exists in. It's just a statement, that's it. It really just reduces to mere opinion, right? And you know, in quantum mechanics, it reduces to mere interpretation. It's just what's being interpreted. It's just a chosen convention, right? But randomness in and of itself has no justification. It hasn't been explained. It's simply been assumed. Hasn't never explained its properties. Never explained, you know, how it works, how it functions. You can't write it down on a piece of paper and show it to me and then let me see and work out how randomness works, right? You say it's there, sure. They say, oh, well, it's there in the quantum mechanics equations. Like, well, no, but it's not really there. You're just interpreting them that way. I want to know randomness in and of itself. You see the problem there? What's that getting into? That's getting into the mystical, right? Randomness is mystical. Because it's just like saying God. It's like, okay, well, define God for me. Show me how it works. Write it down. It's like, well, it's just, you know, reduces to an opinion, right? And then people will say, like the Abrahamists might say, oh, well, God is in the details, working behind it. It's like, well, how exactly? Can you explain to me how? And someone might have an idea, an opinion. Well, this is how. And then I'd be able to say, well, okay, can you really prove that? Well, no, it's just what we think. You know what I mean? So randomness is mystical. Randomness is randomness fails the test. Randomness falls into one of the two deaths for philosophy, for trying to explain why existence exists. It reduces to the mystical, right? It has no explanation, has no ontology, and you can't understand it. Okay, has no properties. You can't write it down. You can't show how it works. You can't even, you know, directly measure it and demonstrate it. Like do an actual empirical measurement that actually demonstrates randomness. Sure, you're interpreting the equation, but in fact, the equations are just, I mean, Nepal, you might know this, that the quantum mechanics equations are summed, right? They're summed over a series of states, right? So they're a net result, right? So that doesn't mean that underneath, it's just interpreted that underneath it's all random, but really it's just underneath, you're just summing over all possible values because you don't know what could it be or what it could be. Anyway, too much detail there maybe. So anyway, so what's the difference for mathematics though? Mathematics does have ontology and it does have epistemic justification. Mathematics is not mystical, right? Mathematics doesn't reduce to mere opinion. With randomness, you just have to accept it like religion. But further, with mathematics, you can comprehend it. You can write it down and show precisely how it works, free from opinion. You can prove that it does what it says, and others will find the same thing. You can understand, justify, and demonstrate the answer of something reducing to net nothing. You can demonstrate that with the math. And you also then, if you're founding existence in this fashion, now you get the added bonus of explaining why science works, of explaining how we can do science and why science uses this tool of mathematics. And we can answer Wigner instead of just thinking that math is a wonderful but accidental and mysterious tool that we have no justification for. Now we do have fundamental justification for it. So that's quite handy. That's quite nice, isn't it? How great is that? So going back to this slide again, mathematics does not reduce to mere opinion. There is not mere opinion in mathematics, is there? There's only one answer. It doesn't depend on who's doing it. And it's either right or wrong. And further, the ontological aspect of mathematics is that you can fully study its nature and its properties and its being and how and why it exists in the way that it does. And it's really simple tautology. It really reduces to simple tautology. 1 equals 1, 1 plus 1 equals 1 plus 1. And you just write 1 plus 1 is 2 now to make it easier. And boom, you have all numbers. And then with some algebraic manipulation, you find that, oh, well, you need the imaginary axis to be complete. And once you have that, then you are totally complete. And you find no more other possibilities. And there you go. You have a complete system that you can completely understand. You can completely understand its properties and share those properties with others, and they will find all of the exact same conclusions, right? You can't do that with randomness, but you can do that with mathematics. Yeah, that was the last slide. So there you go. I hope that makes a difference, right? So how is math, so how is math better? Well, math is better. I guess the question was how is nothing better, but that actually reduces to the question, how is math better? I should have wrote that down, but I just thought of that just now. So you're asking, how is nothing a better explanation than randomness? Well, in fact, that question to an ontological mathematician is asking, how is math better than randomness? Well, math is better than randomness because you can understand math, because you can demonstrate that it does what you're saying it should do, something reducing to net nothing. You can demonstrate that and prove it. You can't do that with randomness. You just have to accept it, right? That makes randomness religious. That makes randomness mystical. And it makes it a religion, doesn't it? And that's why they get so upset, perhaps, about it being questioned, perhaps, right? Okay, Nepal, great question. Thanks so much. Thanks so much for participating. Really appreciate that. And yeah, feel free, guys, to send me questions like that. Okay, anyway, rambling now. I don't want to stop because this was just so fun. Can you tell? I want to keep talking about it. Okay, so great stuff. Have a good night. Bye-bye.